Okay, 10.1. This section is what's called radical expressions. So what a radical expression is, and you've seen them before, you probably maybe just have not heard them, called radicals, but when you see this symbol right here, that's a radical symbol. Sometimes there's not a number in there, that means it's a square root. Sometimes there is a number in there. This number is called the index. So if there's not an index number, it's automatically a 2, which means the square root, which means when you have a number that's inside here, you're trying to find what number times itself 2 times gives you this 25. Well, what times itself is 25? 5. This index number, what it's asking you is when there's a number underneath here, it's saying what number times itself 5 times gives you this 32. Well, let's see. Let's just start with 3. If I multiply 3 together 5 times, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I'm already to 81, and I still got another 3 to go. So it's not gonna, 3 is actually too high, right? Numbers start getting big really fast when you start multiplying them times themselves. So let's try 2. Let's see, 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32. So this means the number times itself 5 times to get 32 is 2. Now, I'm also going to show you that you can do this number part in your calculator. Square root has its own button. If you look on your calculator above the x squared, you'll see that little square root. If it's blue, what does that mean I need to do to get to it? I've got to push the second button, square root. Then you can, oh, I'll just turn it off. So second square root, type in, let's say 49, gives you 7. Fifth root does not have its own button, but here's the thing. I can still do this in my calculator. If I have the fifth root, let's see, whatever root you're trying to take, you push that number in first. So I'm pushing the 5. Now, you're going to go to the math button, and you're going to go down to this little radical symbol that's got that little X right there. If I go down to the radical symbol that has the X and hit enter, that 5 that I just punched in, look where it is. It put it in the index spot. So you can do these in your calculator. You type in whatever root you're taking first, then go to math, and then down to the radical that has the little X. And when since I already typed in 5, it's going to put 5 in that little X spot. And then just type in whatever you're taking the fifth root of. So the fifth root of 32 gives me 2. So you can do these in your calculator. Okay, let's talk about different perfect square numbers, which we've dealt with these a lot because we did the difference of perfect squares in our factoring section, right? So let's see, let's just list the first 10 perfect squares. So let's see, 1 squared would be 1. So 1 is a perfect square. Whoops, you can't see that. So the numbers that are going to be right here are going to be your perfect square numbers. What is 2 squared? 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. Let's let's see, I'm going to go to 10. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So that's your first 10 perfect square numbers. All of these numbers in this column are called perfect squares because I squared something to get them. And also, let's make another column. So I'm going to do a square root of all of these numbers. So what's the square root of 1? Which means what times itself is 1? Well, 1 is. It's whatever I squared to get it. So what's the square root of 4? What times itself is 4? 2. So if you know a lot of these offhand, you don't have to trust on your calculator so much. It's always there. It's always there as a crutch. You can always use it. What's the square root of 9? 3. Square root of 16. In other words, what times itself is 16? 4. You see where I'm going with this? The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. So do you see the relationship where you square something, and then if you take the square root of whatever that number is, it gets you right back to what you just squared, right? Because that's what you're doing when you're finding the square root. You're saying, what squared gives me this number under the radical? So the first several problems in 10.1 are just going to be some of these. So let's see. Number 1 is the square root of 25. Well, what times itself is 25? 5. See where I'm going? There's a whole bunch of these. Number 2 says, what's the square root of 81? Well, what times itself is 81? 9. Number 3, the square root of 64. What times itself is 64? 8. Now, when we get to number 4, we do see something a little different. 4 and 5 both have negatives, but they're on the outside of the radical. If you're on the outside of this radical symbol, you're just coming over. You don't have anything to do with what's going on underneath. Nothing. You're just bringing this over. Outside comes over. Doesn't affect what's going on here. So I just brought this negative over. The square root of 100 is 10. So this is the way you would say this out loud is, what is the negative of the square root of 100? The negative of the square root of 100 is negative 10, right? Because the square root of 100 is 10, which means the negative of 10 is negative 10. Okay, same thing on number 5. You have the negative of the square root of 144. So 144 was not in the list, but that doesn't mean it's not a perfect square. What times itself is 144? 12, right? 12 times 12 is 144. So I would bring the negative over, and it would give me the negative of 12, which is negative 12. If you're unsure, these can go in your calculator, right? You would type in the negative button. Square root, since these are square roots, I don't have to go to the math function. Square root has its own button. I just need to hit the second since it's blue. Type in 144. So negative of 144, and there it is, negative 12. Okay? Now, looking at number 6, I see a fraction, and it makes me very nervous because I'm combining fractions and radicals. Now, here's the good thing. Is 9 a perfect square? It is. Is 64 a perfect square? It is. So if you're looking at a fraction under a square root, but they're both perfect squares, it's kind of like you treat them separately. What is the square root of 9? It's 3. What is the square root of 64? It's 8. That's all you have to do. Just take them separately. Do the top and then do the bottom since they're both perfect squares. Now, it does get a little more complicated if one or both of them are not perfect squares, but we're not getting to that yet. Okay, number 7, you have the negative square root of 81 over 4. My negative's on the outside, which means I'll just bring it over. These are both perfect squares. The square root of 81 is 9. The square root of 4 is 2. So negative 9 over 2. All right, number 8. Let's see, I have square root of negative 25. Let's look at the difference between these two things. All right, this is the problem. I'm just going to show you the difference about where those negatives are. We've done a problem like this. A negative on the outside does not affect what's going on in here. So the negative of the square root of 25 would just be negative 5. We've done that problem, or a problem like it. Here's where we have it done. If you are trying to multiply something together and get a negative 25, and it's the same thing, right? So how do you get negative 25? You would need 5 times what? Negative 5. But are those the same number? No. You're not multiplying the same number together, which is what you're trying to do to get what's under here. So if you are a square root and you're a negative underneath, that just simply means the square root is not a real number. Not a real number. If you tried to type that in your calculator, so again, second square root, and you put negative 25 under there, look what your calculator is going to tell you. Non-real answer. It's not a real number answer. Okay, so that's the difference. Negative on the outside doesn't affect it. It just comes over. Negative on the inside of a square root is not real. Okay, like number 9. You have negative on the outside, square root, and negative on the inside. This is like saying, what's the opposite of this non-real number? You're still not real, right? So this right here, this, if there's, again, if it's square root and there's a negative underneath, this right here makes this not even count, right? So this right here is non-real answer. All right, number 10. Now, remember we talked earlier, there could be other numbers in this index spot besides a square root, which means now the number that I'm going to put under here, I'm trying to find what number times itself 3 times instead of just times itself 2 times. What number times itself 3 times gives me 27. It doesn't mean to divide that by 3. That's not going to get you your answer. What number times itself 3 times gives you 27? Let's just check the 3. What's 3 times 3? 9 times 3 again is 27. Which means the number times itself 3 times that gives you 27 is 3. Now remember, you can do these in your calculator. If you're not doing square root and you're doing any other root, type in your root number, which is 3. Now go to math and then down to number 5, right? The little radical with the x, because what's it going to do with that 3 that I just put in there? It's going to put it in the index spot. It's going to put it in that little x spot right there. So cube root now is what's written. So that's different than just writing a 3 in front of your square root. It's putting the 3 up in the root spot. And then 27 gives you 3. Okay? All right, number 11. I've got the cube root again of negative 512. Now, remember when we had square roots of negatives, that was not real. Because I cannot multiply the same exact number together in order to get a negative anything. If I'm going to multiply numbers together, 2 numbers together and get a negative, I'm going to have a positive times a negative. But you can multiply a number together 3 times and get a negative, because what is a negative times a negative is a positive. But if you multiply that same number together again, it's a negative, right? Negative times negative is positive, but then you'd have a positive times a negative, which is a negative. So I can work this if it's a cube root or any odd number root. Okay? So if this is a 5th root or a 7th root or a 9th root, then you can do this. So this number, it's just going to be a negative number, right? So let's try negative 5 and just see where we get. Negative 5 times negative 5 times negative 5. So I multiplied negative 5 together 3 times. Let's see, negative 5 times negative 5 is positive 25. But if you multiply that times negative 5 again, it's going to give you negative 125 to load, which means my number is going to be higher than, well, it's going to be, I need to use something bigger than 5, right? So let's try 7. Negative 7 times negative 7 times negative 7, right? I know I need to use a negative because 3 negatives when you multiply them together give you a negative. Negative 7 times negative 7 is positive 49. Bring down that negative 7, and 49 times negative 7 gives me negative 343, I think. 49 times negative 7 gives me, yeah, negative 343. Too low. Let's try the 8. I'm closer. Negative 8, negative 8, negative 8. Negative 8 times negative 8 is positive 64. Bring down that negative 8. So I've got 64 times negative 8, which gives me negative 512. So what number did I just multiply together 3 times? And it gave me negative 512. Negative 8 is your answer. So can I do that in my calculator? Sure, why not? It's another root, not a square root. So I'm going to put my root number, hit the math button, and go down to 5, because again, it's going to put that little root number in that x spot. So the cube root, what am I finding the cube root of? Negative 512. Remember, your negative button is here. Negative 512, negative 8. So you can do this in your calculator, which I'm probably going to do on number 12. So negative 5th root of 3125. What does a negative on the outside do? Just comes down, doesn't have anything to do with what you're doing here. I don't want to mess with trying to find this on my own. So what root number am I taking? 5. So I'll hit 5, go to my math, down to the little x square root, so down here, hit enter. So there's my 5th root. What am I putting in? 3125, enter, 5. So I already brought the negative down. The 5th root of 3125 is 5. So -5 would be your answer. Number 13. Negative on the outside, cube root, -8 on the inside. Negative on the outside comes down. What is this going to give me? What number times itself? If you want to put this in your calculator, go right ahead. Cube root of -8. It's not going to be a big number. If you're multiplying a number together 3 times and you're only getting the -8, you're not going to be using a very big number. Let's try -2. What's -2 times -2? +4. What do you get when you multiply +4 times -2 again, though? -8. So this part, the cube root of -8 turns into -2. But what does this negative on the outside do to that? What's a negative of a negative? +2. All right, let's look at 14 and 15 together. 14 says, what's the square root of 15 squared? And the other one, the last one says, what's the 6th root of y to the 6th? If your root number, which if it's a square root, it's kind of like it's an invisible 2 right there, right? If you are taking the square root of something squared, those two things are opposites of each other. And what do opposites of each other do to each other in math? They cancel each other out. Plus cancels out minus. Division cancels out multiplication. Square roots cancel out squareds. Your answer is 15. 6th roots cancel out 6 exponent. You're just left with y. Okay, so don't make those last ones any harder than they are. If your root and your exponent are the same thing, they just cancel each other out.